Alright, so we are back today with yet another K7000 that is blowing the fuse. And this is a 19-inch with the 7-pin configuration on the neck. And I have already gone through and verified the fuse is open and the HOT is shorted. And if we look here, there is a tag that says blue fuse, dead HOT. So the HOT is actually shorted and not dead. There is a difference technically. But I've also gone through and checked all the normal causes of that, and everything checks okay. So I thought this might be a good video. You know, I've already got a dozen or so of these, I forget which number this is, of this exact problem where it's blowing the fuse or HOT shorting, things like that. So I've gone through on every one of them what to test, what to look for, how to check things, and you know, this will be no exception. I'll go ahead and do that again on this video in case this is the first one you're watching. But I've already gone through and done all that, and everything checks okay. R103, the rectifier diodes, R104, R101, R97, R89, R88, R96, C38 width cap, voltage regulator, all that stuff checks good. D18 is good in here, but the HOT is in fact shorted. It's reading 24 ohms or so, and the B plus resistor is good, so everything is good that you would normally suspect or be bad that might be causing a shorted HOT or blowing a fuse. So this one I thought might be a little bit interesting. So we're going to go ahead and document it. Now it does have the original white knob flyback, and it seems to be in relatively good shape. I don't see any outward symptoms or indications of it being cracked or arcing to the frame. So I don't think that's our problem. However, there are a couple of issues I want to point out here regarding solder joints. Like on just a general inspection after taking a look at it here, we do see that there is a cracked solder joint here on our flyback. Right there, it's very obviously cracked around there. So we do have that issue, and that does lead directly to one leg of our HOT here across the C36 width cap. I'm sorry, C36 safety cap. The C38 width cap is actually these two connections here. But across one leg of, so these two legs are connected and these two legs are connected. This is a 4-pin big fat critical safety cap, C36, and these two pins are connected across each other. So basically this broken cracked joint is going directly to the collector of the HOT. So that could be a direct cause there, is this cracked joint. So, you know, this may be a situation where the HOT is going bad in circuit and shorting and then causing the fuse to open up because of this bad cracked solder joint. You can get a better shot of it there. So I think, based off all of my preemptive testing, that this is the cause of our issue. It's just bad solder joints on the flyback, especially this one. So what we'll do is we'll go through and do all of our normal testing and checking and repair procedure for bad joints and things, and then we'll go ahead and reflow that flyback, and then we'll reflow our header pins because those are real dry and cracked as well on almost every one of these if they haven't been redone. So the caps are original, so we're going to cap it, reflow it, repair it, fix it, what have you. Get all the normal rework done to this that I normally do, and then we'll test it out. None of the pots are broken. It's always important to make sure none of your adjustment pots are broken before you power it up. None of our color pots on the neck board are broken, so that's good. We are going to need to reflow a little bit of the neck board too, but not a big deal. So you've got a K7000 that is shorting the fuse, or sorry, shorting the HOT and blowing the fuse. I'm betting 1,000 today. What do you check? Well, the first thing that I would suspect would be this was hooked up to a non-isolation transformer setup, and in that case you're going to have D20 and D21 here. These two rectifier diodes are going to be shorted. However, they're not. The easiest way for you to test that is to just go right to R104. If R104 right here reads like 5 ohms or so, then those rectifier diodes are shorted, and it's just in a quick and easy test to verify. So if we go to R104 and we test that, it should be about 15 ohms. And it is exactly 15 ohms. Now, if this read 5 ohms or 7 ohms or something, then it's likely that one of these diodes is shorted. But the fact that it reads 15 ohms means they're all fine. But just for the sake of completion, we'll go ahead and test it here. So here's a D19, 0.5 voltage drop, D20, 0.48, that's fine, 21, 22, 24, and 23. So all of our rectifier diodes there are good. R104 is good. R103 is this guy over here that's directly off of the power circuit for the incoming AC through the filter cap, and that should be 2.7 ohms, and we get 2.9, which is totally fine, 2.8, so that's not bad. So all that's good. We can check R101, should be about 4.5 to 5K in circuit, and that's this guy right here. However, it's going to read low because our HOT is shorted. So you see here we're reading 4.3. It should be closer to 4.5 to 5K. We're at 4.3K, and that's because our HOT is shorted. Now, after we take this out of circuit, we'll test this again if I can remember to do it, and you'll see it's higher, 4.5 and higher. So if you have a lower reading on that, check to make sure your HOT is shorted, or not shorted. See if it is shorted. How about that? Which we'll get to that eventually. Then we'll check R88 here. Should be 1.8K, and it is, which is, of course, this guy right there. Right here. R96 is this large one here next to R89, and it should be 1.8K also, and it is 1.8K. Yeah, then we'll check R89, which is this 3.9K, this big ceramic 3.9K. We get, if I could get on the leg there, I can't get on the leg. What in the world? Did I forget to check that the first time around? I think I might have. No, it's good. 3.9K. I wasn't sure. I'm pretty sure I checked everything, but yeah, 3.915, so that's fine. It's always a good idea, really, to measure on the bottom side of the chassis as opposed to the top, but we're good there because the legs can get oxidized and give you alternate readings, and you'll think the part is bad when it's not. We have a bad reading because the legs are oxidized, but so that's good. R97 here should be 270 ohms, and it's 271. We'll check C38, which is the width cap right there. You're just checking to make sure that it's not shorted, and we get 124K, which is, it should be in the mega ohm, but I think we're reading that because we got a shorted HOT. Normally it shouldn't read that. It should read, you know, start climbing into the mega ohm. So we'll take the HOT out and recheck C38. We'll also recheck, see, I forgot already, R101. And then now we'll check D18, which is a diode down in here across the horizontal windings for the yoke connector. We're going to go to diode mode, and negative is this pin here, positive is here. Should get 0.45-ish voltage drop. 0.5, so that's good. Okay, fine. And the solder joints here on the yoke header pin here and D18 are almost non-existent, so we'll have to reflow those. Very critical you do that. Okay, so that's all good. Now, I guess the last component to test is going to be our voltage regulator. Now, you go to ohms, and you should get around 200 ohms. This resistor here is 220 ohms on the 19-inch, but there's an additional resistor in parallel, which will drop it down to about 200. So we should get around 200 ohms. If we get 0 ohms, then our regulator is shorted, and we get 200, 197.3. So the regulator is not shorted. It doesn't mean that it's not faulty under load. It just means that it's not shorted. So that all tests okay. Now this has the wide fat one, and you can also just go to pins 1 and 4 here, which will also read directly connected to that resistor. So that's why it's easier to just go to the resistor, but that checks good. So our all of our power rail components are good. Now, we don't want to overlook the fact that it could simply be bad caps. It could be bad caps also, but my hypothesis is going to be this cracked joint. Now, I want to try this. I want to fix this cracked joint, replace the HOT, and then install my circuit breaker across the fuse holder and try it without doing anything else, because I want to see if the problem is simply that cracked solder joint, which I'm going to be confident that it is. I'm also going to reflow. See, these joints are intact for D18 and the horizontal coil connection here, but they're pretty thin, so I'm going to hit those too. But for the sake of entertainment here, I'm just going to replace the HOT and put the breaker in place of the blown fuse, and then see what it does after reflowing those joints. So that's the last component to test, except for our critical safety cap with the guy right, the big green one right there. Now, the way you test this is you put your meter in diode mode, and you want to check diagonally across these pins here. So if we zoom in, you want to check diagonally across this way and diagonally across this way. So here to here and here to here. But it's going to read shorted. And it reads shorted because our HOT is shorted. If we check our HOT, center leg negative to each outer leg in diode mode should get 0.47 voltage drop, give or take. And we get 23 ohms to each leg. So the question now is, the HOT actually shorted, or is it the critical safety cap that's shorted? If the critical safety cap is shorted, it will definitely take out the HOT. So it could be a symptom of a faulty critical safety cap. So in this case, we got to take the HOT out of the circuit, because it's easier to take the HOT out of the circuit than it is the critical safety cap. If we take the HOT out of circuit and the critical safety cap no longer reads shorted, then we know that it's fine and not the cause of our problem, and it's most likely back to our cracked solder joint here, going right to our HOT off the flatback leg. So let's go ahead and just begin by taking out the HOT, and then once we get the HOT out of there, remind me, I'll check R101, and then we'll recheck the critical safety cap, and we'll recheck what else? Oh, and the width cap. Like I say, the width cap C38 should read like in the mega ohm and start climbing up. It shouldn't read 124K. So we got to check those three components: C38, the R101, and the critical safety cap. So don't let me forget those in that order here. So I'm going to turn my little fan on here, acting as a fume extractor. So if you hear the noise here, or vibrations, that's what that's from. So sorry about that. But all right, here we go. Enough jibber jabber. Oh, a little more there. Okay, that should be good. Let's get that out of there. Yep, okay. So, you also don't want to overlook a bad insulator. The insulator that goes on the back side of this HOT could have a little pinhole in it, or a crack or something, allowing the HOT to short to the frame. And it looks like this has never been removed, because all of this thermal paste aligns directly with this insulator. This has never been removed. So yeah, now with the HOT out of there, we'll recheck our C38 and see if it reads in the mega ohms still, or 124K. Yeah, see, there you go. Mega ohm, 1.6 mega ohm. So that's correct. Now, R101, which we can just go across the traces here, which is this and this, should be about 4.5 to 5K if I'm correct. Yeah, there you go. 4.9, 5K. So that's good. And then our critical safety cap, we'll go back diagonal, should read, I believe, not open, but let's see what it reads. There we go. That's not shorted, and that's not shorted. So there you go. All of our power components checked good. So actually, you know what? Let's go ahead and just do a light bulb test. The easiest way to do the light bulb test on the K7000 is to remove the HOT, which we've already done. Then you can grab a 60 watt incandescent light bulb. It doesn't have to be it can be any LED, it can, any light bulb. It can be an LED light bulb is what I should say. Because you're really only worried about whether or not the light bulb lights up. This does not have a B+ pot on it to adjust. It's regulated by the regulator. So it doesn't necessarily have to read correctly. As long as it doesn't read, you know, 80 volts, it should be about 123-ish volts. So we're going to attach a lead to ground and a lead to, I believe, the blue wire on our resistor. So we're looking for about 123 volts. As long as it's somewhere around there, you know, 125, 127, 122, whatever, you're fine. When you get down into the 80 volt range, then you have a problem. And in that case, you likely just have a faulty voltage regulator that's failing under load. So that has happened before. I think I might even have a video on that. That's because I'm on that. On ohms. Is that? That's, oh, I'm reading through the light bulb. That 18 ohms resistance is the light bulb. See? So, all right, so let's just go to volts DC. Let's grab the power. And, okay, let's connect our power. That's good. Okay, now, I talked about, normally you have to connect the light bulb to the collector of the HOT, but I think you can do it this way. And it's not going to work with the bad fuse. And yes, the fuse is bad. I think I forgot to show it. The fuse is bad. So let's go ahead and just connect my circuit breaker, a little 2-amp circuit breaker. And if you want to get yourself one of these, the part number is 7277-2-2, and it's a little 2-amp circuit breaker. So, all right, I think if I recall correctly, if this doesn't work, we'll have to attach the other leads of the bulb to the collector pad of the HOT, but let's just see if this works. Yes, it does work. Okay, I thought so. And there you go, 122. And it should be 123. So our power regulation circuit, good. Quick and easy way to eliminate anything in the power circuit is our problem. So that's good. And you can see that it dissipates down to 0. We don't have to worry about discharging the filter cap because the light bulb has a load on the system and automatically discharges the setup and the filter cap by being a load. So you'll see here we have 0 residual voltage. So you can immediately handle it after doing this because the light bulb has discharged the filter cap. So that's all good. And with the HOT out of the circuit, the flyback does not power up. So you can actually turn this on without even having the light bulb hooked up. Now you'll have to discharge the filter cap manually, but you can operate this without the HOT installed, and you don't have to worry about the flyback energizing high voltage. And that pretty much goes for any chassis that you work on. With HOT out of the circuit, the horizontal section will not power up, and there's no danger of the flyback energizing on you. But take that with a grain of salt because I don't know what you're working on. Okay, we can get rid of these now. And I think we are ready to replace the HOT and reflow these bad joints. I want to reflow. See, these joints are intact, they're just very bad. So I want to reflow these. And we're just going to add a big bridge across here, like so. Perfect. And now we will hit this broken joint here on the flyback. If the pin's a bit oxidized, you can use your soldering iron tip and just kind of scrape on it, and that'll bring it back to life pretty good. So, all right, that looks good to me. And let's go ahead and, well, I don't really want to reflow all these completely because if the flyback is faulty, I don't want to have to worry about extracting a whole bunch of extra solder. The rest of these joints are intact, so I think that'll be good just like that. So I also want to hit these, because these input header pins are right on the verge of pretty much having nothing on them. So these are not going to cause the issue at all. I just want to go ahead and reflow these before I forget. They're part of the normal reflow process, but I just want to go ahead and do it right now while I got it on my mind, because I'm at the age now where if I don't do what I'm thinking about doing immediately, I will forget, guaranteed. I'll be sitting there watching TV and I say to myself, I need to remember to do this tomorrow. Well, or I need to remember to set this aside for tomorrow, and if I don't get up and do it at that exact moment, I will forget, guaranteed. So, all right. Now, let's take a look at other stuff here and just make sure nothing else looks amiss. And, yeah, R101 looks pretty shabby, but it is intact. Same on this side. R104 is notorious for having cracked joints, and those are pretty thin, but they're intact. The thermistor here for the degal system is also notorious for having very bad joints, and those are also not very thick. They're pretty thin. There's almost nothing there, but they are intact and not cracked. So I think that's about all I want to do before we try this. Let me go ahead and actually, as I say that, I want to hit the other leg of D18 here. Like I say, it's not cracked, it's just pretty thin. And the other leg of the horizontal pin for our deflection. And okay, so that's all I really want to do. Now, that's about all I see. So we're going to get another HOT installed, and then I just want to try it. And if it blows the well, I'm going to use my circuit breaker, but if it doesn't energize immediately, like if you turn it on and you don't hear energization, high voltage, you know, almost immediately, I'm going to cut the power because that means it's not working. And using the circuit breaker will save me $3 per fuse, if you will. And where are, looking for my HOTs here, there they are. I actually have one, oh no, this is a 2 amp. The 19-inch uses a 1.5 amp, and we need to find a 1.5. The 25-inch uses a 2 amp. The 19 uses a 1.5. So I've got some in here. I'm 99% sure that I have the 1.5s in here, and it's not looking good, guys. I do not have any 1.5s. That's interesting. What's this random one down here? 3 amp. Well, I'm not using that. I think that came off another chassis that somebody had a 3 amp in there. Do I not have? Well, I guess I don't have any 1.5 amp fuses. I'll have to... well, that's a bummer. Yeah, definitely not. Huh. That's hard for me to believe, because I don't think I would have used them all and not ordered more. Yeah, this isn't... sometimes the parts fall down into the little tub below. Yeah, they're not... Oh, like, you know, case in point. This U1 here fell down from my K7000 tub into the tub below it in the little organizer up here. So that's why I looked in the Amplifone one here real quick. But, and I got an Amplifone parts tub because I have an Atari Star Wars, and as anyone who has an Atari Star Wars knows, the deflection boards like to go bad on you. So I got extra parts for every so often when that happens. But okay, HOT. And you never want to overrate... Oh, that one's got a missing leg. I cut that leg for some other purpose, and I don't want to deal with that right now. Okay, are we sure this is 2 amp? We'll have to take this out and see here. Yep, it's 2 amp. Well, you never want to overrate, but I think 2 amp versus 1.5, it's not going to, nothing's going to explode with that half amp. Besides, it's overrated anyway. This only runs at like 0.7 amps. So anyway, okay, so let's get this HOT in here, and then we'll get it on the tube and fire it up without doing any other work, because I just want to see if those joints were the cause. Oh, come on, you lazy rotten bum. All right, so to keep this on there, I'll get the screw. Then we'll feed this through here, like so. Okay, success. And our center leg, our collector leg, is not in contact with the frame, so that's good. And I'll be damned if I can't find my... Here they are. It's easier to get yourself some tweezers here and grab this nut and hold it on back here and feed this through. And nice and snug, doesn't need to be completely torqued on there, so that's good. Now let's reflow it, or I guess technically flow it. Even flow. Alright, so that's fine. Now, out of curiosity here, let's check that critical safety cap. Should read the same as the HOT, about 4.5 voltage drop, 4.7-ish. So if we go diagonal here, on the right setting, there you go, 4.8, diagonal, 4.8. So you're reading across the HOT when you do that. That's why this reads shorted when this reads shorted and vice versa. So all right, I think that's all I want to do, and this will test it, and if it still has issues, then we'll probably have to attribute the problem to caps or a bad flyback. So we're going to test it, but for now we'll set that aside, and let's just check this HOT out of circuit. It was 24 ohms, if memory serves, something like that. Yeah, 25 ohms, 35 ohms. 60 ohms, so that's a goner. All right, let me grab a tube. I'll come right back and we'll have this hooked up. We'll see what happens. All right, so everything is connected. I've got my circuit breaker installed on the fuse holder, and we got our anode, neck, yoke, ground, power, video, remote. Of course, I say that I just always count to 7, even though there is no remote. It's all pots are on the board, but I always say that to, make sure everything's okay. If this does not power up immediately with high voltage, we're going to shut it down as soon as I can to try and save the HOT from getting shorted. But I'm confident with everything checking good and the light bulb test being good that this should work, and it just came down to either faulty, well, most likely faulty solder joints, but if not, then it likely is a bad flyback is all it really left it could be, or I guess bad caps, but usually bad caps won't cause HOT to short. With what we found on those solder joints, I'm pretty sure that's it. But okay, enough digressing here. I do have a 19-in-1, horizontal 19-in-1, because I have a Versa Super Mario Brothers project coming up, and I have this set up to only be on Super Mario Brothers, so that's what we should see. And also, these produce a very narrow image, so it may be super narrow on the screen. I'm not going to worry about that. I'm only interested to see if it turns on, provides a picture, looks good, and operates. So let's see. Cross our fingers here. 1, 2, 3. Yes. As expected. And what do we get? It's working. We're flipped horizontally, and we need to adjust our vertical hold here. There we go. And she operates just like I thought. Faulty solder joints. Now I can't crucify the solder joints, for lack of a better term, because I don't know if those were the actual fault, because the card here that came with this, wherever it went, it just says blue fuse, dead HOT. Now, The email I got with this that was sent in said that it keeps blowing the fuse. Well, I guess it would, wouldn't it? No, it said keeps shorting each. Okay, I'm sorry. I'm going off memory here. The email said keeps blowing the fuse, or shorten the fuse. So I'm pretty sure that it was a situation where it... Well, no, I'm not sure, because that HOT had never been removed. It was obvious it had never been removed. Maybe they misspoke, and maybe I misunderstood, but it keeps blowing the HOT is what I thought it said. But it makes sense now that it would have kept blowing the fuse if the HOT was shorted. And then HOT had not been removed. That was the original one for sure. So I think I don't want to condemn, it's probably the word I was looking for before, and it's not crucify. I don't want to condemn the bad solder joints because it could have just been a situation where the HOT failed over time. But I'm pretty confident that the solder joints were at fault. But regardless, our testing and quick repair has produced a good, valid result here. So I'm going to do the reflow, do the cap kit, let's adjust our focus here. Make sure that we have good focus. Ah, wow. Look at that. Wow. That is crisp. Okay. Of course, colors are wrong and the screen's backwards and our image is backwards. Hey, that's not bad. And like I said, it is pretty narrow. So that's because these multi-boards are like that. And a dead giveaway, an absolute dead giveaway that this is a multi-board, not an original board, is that it had the year underneath the Super Mario Brothers there. If we start here, actually, no, I got to reset here. Hang on. We'll do a hot reset. I just want to show. See, 1986. So it's a dead giveaway that someone's got a multi-board installed. If you ever go up to a machine and it has the year it was made like that, multi-board. So anyway, all right. So we'll turn it off, and I'm going to do the reflow, the cap kit, get everything all fixed up, and we'll go over it. And we'll test it one more time and call it good. All right, approximately 45 minutes later, here we are, all done. So cap kit, reflow, double checked other components, and everything's good to go. So there are a couple of things. Oh, I also got it all nice and clean, which we'll see here shortly. But there are a couple of spots and places that I want to talk about reflowing that a lot of people overlook. Most importantly is the R105 thermistor for the degal circuit. A lot of people forget to reflow that, and over time, because this runs very hot, those pads can get broken and oxidized. And I've actually seen chassis arrive to me for repair, and the entire thermistor is missing because it fell out in the box from vibration. So something like that. The other component is this cable here, this 3-pin ribbon cable. You can't see this 3-pin ribbon cable here. The solder joints from right here to right here is for the vertical circuit. A lot of times these get very thin and break as well, so you also want to pay attention and reflow the solder joints on this ribbon cable. And then lastly, the horizontal width coil. The width coil, when people try to adjust it, it bends it back and forth, and a lot of times it can crack those traces and those pads on the width coil. What will end up happening is you'll have high resistance from the cracked bad joints, and it'll literally burn this all up. I've seen it before. So you want to make sure when you do your reflow to hit the horizontal width coil, the ribbon 3-pin ribbon cable here, R105 for the thermistor here, and also Q10. Q10 is right there. It's this little transistor right there. The solder joints on Q10 also get very thin over time. They're pretty thin from the factory, so those are something you definitely want to reflow as well. So those components there you don't want to overlook. A lot of people end up doing that. But we got this all completely recapped. Every capacitor is replaced, and all the joints are reflowed. Everything's nice and clean. And I do want to mention I also did the stuff I normally do, like beefing up the connections here for R101 on both sides, and the pads here for R89, this one and this one right there, this one and this one. So R89, R101, got those pads all beefed up, video input header pins reflowed, everything else reflowed, all the header pins for the yoke connection Everything that you normally would hit has been hit, and it's all nice and clean and looking good and ready to go. So with all that being said, I did also reflow all the joints for the flyback. So this flyback is in good shape. It appears to operate fine. It's not heavily cracked or broken. There's no evidence of it arcing. There is a tiny crack right here and a tiny crack down here, but this front of this box is kind of isolated from the high voltage section, so it's not going to leak out the front from these cracks. It might leak out the side over here or the top, but if you have some small cracks on the face here by the pots, on the white knob flyback, or really any flybacks, most of the times it's not anything to really worry about. It's not worth replacing this flyback because A, it's not arcing, B, it works fine, at least as far as I can tell from running it for 5 minutes. These two cracks aren't not enough to replace it because it's working. So I would wait until it fails for something like this to change it out. So that all being said, I got this reflowed as well. So let's get it hooked back up and do some fine tuning and see how well we can make it look. All right, everything's hooked up once again, and I do have the 2 amp fuse in there. It's not going to hurt it to run on 2 amps versus 1.5. That if something does go short, that 0.5 amps is not going to keep the fuse from blowing long enough to cause damage to something else. So it's fine. So I'll leave that in there. And I am still running the Mario Brothers or Super Mario Brothers PCB here. So I'm not really concerned too much about adjusting colors because all the colors are present, and this is not going to stay on this tube. So I'm not going to worry about adjusting colors or screen size position. We're just going to make sure everything is operational, and we'll call it good. So take number 2 after the cap kit and reflow. Let's see if it still works. Here we go. 1, 2, 3. Yes. And let's see what we get here. And it works. And not only does it work, but it looks very good. Now, I probably do need to adjust the focus a little bit again, since after the cap kit things changed. So let's see if we can. That's good. Look how sharp that is. That is good. Nice. Okay. Well, let's turn up our colors or our brightness slightly and contrast slightly. That's about right there, and it looks pretty good. Now it looks a little washed out in the viewfinder, but in person, probably in the video here, it ends up being pretty good. So that's actually really nice. Colors are actually really good right here. I did also make sure that the width coil does turn. So, I mean, we probably could, if we wanted to, just kind of demonstrate that. It's not locked up. I always make sure these move, and if not, I let the person that owns this know, or these know, that it doesn't move. And oh yeah, I mean, you guys don't have a comparison, but and that's about the limit. So like I say, the horizontal size is maxed out now. You can see it's wider than it was, and we still have, you know, 2 inches on this side. And I'll turn the brightness up so you can get a better idea here. There you go. So we still have 2 inches on this side, and, you know, 1.5 inches on that side, but that's because it shifted over. So regardless, that's maxed out. And like I say, the only way to really fix this is to change out that C38 width cap to a lower rating. The lower the rating of the width cap, the wider the image. The higher the rating, the narrower the image. So if you're in a situation like this where you're using one of these multi-boards that has a really narrow image, you have to swap out your width cap to a lower rating to get a wider picture. But that's outside the scope of this video. This is now operational and working and should be reliable, so I will let the person that owns this know that it's good to go. I'll let it run for a number of hours, make sure nothing explodes, do some more adjustments and stuff, but for the purposes of this video, this is now fixed. So again, thank you for watching. Hope you learned something. Make sure you like, share, and subscribe, and we'll see you on the next repair.